So for lesson 97, now we're working with geometric sequences. Geometric, very similar to arithmetic. We still have a pattern going on, but now we're no longer increasing or decreasing by a certain amount, but now we're looking for a ratio, or what I like to refer to as a factor. You know, if we look at example number 1a, we have 6, 3, 3 halves, 3 fourths. What's going on there? Well, we're no longer increasing by a difference anymore, right? But now we're increasing or decreasing by a common ratio or factor. Tanner? Yeah. Therefore, when they want us to identify the common ratio, we're increasing by a ratio of a half, or a factor of a half. 6 times a half will get us 3, 3 times a half will get us 3 halves, and so forth. Let's go ahead and find the next 3 terms. What would the next term be? Well, 3 fourths times a half will get us 3 eighths, 3 sixteenths, 3 32nds. Can we identify the common ratio for part B? -4, 8, -16, 32. What's that? Yeah. And you're going to find when it alternates, your common ratio is going to be negative. Negative times negative gets us positive, positive times negative gets us negative, negative times negative gets us positive, etc. Next couple of terms that we're looking at there. -64, positive 128, and the last one, -256, I believe. Just keep multiplying by that -2. So again, there's a pattern going on there, but again, the difference between the arithmetic, we had the common difference. The geometric, now we're looking at a common ratio. We're multiplying, essentially. Again, we have the formula for geometric sequence. A sub n is equal to a sub 1 times the common ratio raised to the n minus 1. So yeah, wouldn't you know it, we have an exponent now involved in this one. And that's okay. I mean, between the two of them, students like the arithmetic formula as opposed to this thing because they don't have to deal with exponents, but it's the same thing. Again, we're going to use this one if we're given the first term or if we want to solve for the first one. Then if we don't, we'll use m. They want us to find the 10th term of 3, 12, 48, 192. Do we know what our common ratio is? Because again, with lesson 97, we're going to ask the same question that we asked in lesson 92. Instead of asking, can we find the common difference, now can we establish what the common ratio is? What is it? It's 4. Very good. So we don't have to do that first step where we have to solve for it. We know it. That's good. And now if we want to, we can use that first term. So we can use a sub n is equal to a sub 1 times the r to the n minus 1. We're searching for the 10th term, so that's going to be my n value. We know that the very first term is 3. Actually, I want to save that for the next step. Let's go a sub 1. Because then it'll be easier to identify what your n and your 1 is. N is 10, 1 is 1. And now let's go ahead and plug those in. A sub 10 is what we're going to solve for. What do I plug in for ace of 1? 3. What's my common ratio? 4. And 10 minus 1 is going to get us 9. Calculator time. 4 to the 9th times 3. $786,432. Big number, am I right? And that's only the 10th domino. So you can see, with the geometric sequence, these values are going to increase or decrease very, very quickly as opposed to the arithmetic. And what's the reason behind that? Well, actually, you're looking at an exponential growth or decay because you're looking at that exponent. Let's do one more. Very similar. We're going to find the 8th term of 810, negative 270, 90, and negative 30. Again, the first question we're going to ask ourselves is, do we know the common ratio? Yes, very good. It's negative 1/3. You're always multiplying, you're never dividing. So how do we get to the next one? Well, we multiply by negative 1/3. Again, if we want to, we can use this very first term. That's fine. So ace of n is equal to ace of 1 times r to the n minus 1. N value that we're solving for is 8. Ace of 1 times the common ratio, which is negative 1/3, raised to the 8 minus 1. Ace of 1, we can plug that in. We said that was 810. Be careful how you do this. If you want the fraction, you can use the caret button. Make sure the negative is in the parentheses. So parentheses negative 1 divided by 3 parentheses caret 7. Answer that you should come up with. Give me the simplified fraction if you would. When you do it, you should come up with negative 10 over 27. I actually have one more problem I want to go over with you. Can you give me 3 or 4 minutes to get through it? 3 minutes. Find ace of A of the geometric sequence given that ace of 4 is equal to 32 and ace of 9 is equal to 1024. Oh, Jaden, I'm sorry. I'm sorry, but I'm not sorry. If it was Dylan, maybe. Kyler for sure. Maybe Jeremiah.
Dylan?
We want to find the first term given that the 4th domino is 32 and the 9th domino is 1024. Do we know what the common ratio is? Well, the answer is no. Therefore, we need to find the common ratio. This is where we have to include that extra step. Ace of n is equal to ace of m times the common ratio raised to the n minus m. This is the part where we're going to use both of those terms, plug them in, and we'll eventually solve for that common ratio. Again, go in order from greatest to least. So 9 is equal to ace of 4 times r to the 9 minus 4. Well, what's ace of 9? Well, it's your 1024. What's your ace of 4? That's 32. And notice we have our equation with just one variable. We can solve for this thing. Divide both sides by 32. Help me out. 1024 divided by 32. It's 32. And how do I get rid of the exponent of 5? Not square root, but the fifth root, correct? Therefore, what's the fifth root of 32?
2.
Very good. So your R value is the 2. We are just about done. So we have now found the common ratio. We plugged in both of those and found it to be 2. Now we want to go ahead and solve for a sub 1. Just about done. Now we're solving for a sub 1, so if you want to, you can go back to the very first formula. A sub n is equal to a sub 1 times r to the n minus 1. And you can choose whatever you want your n value to be. You can either use the 4 or you can use the 9. Let's go ahead and use the 4. My n value I said was 4, so 4 minus 1. What do I plug in for a sub 4? Well, I plug in 32. A sub 1 is what we're going to solve for. What's my common ratio? We found that to be 2, so here's where we want to use it. Therefore, a sub 1 is 4. You may go. I appreciate